Now that you've looked at adding, subtracting, multiplying with imaginary numbers, we also want to be able to divide with imaginary numbers or complex numbers. I'm going to break dividing into two separate parts. The first part we're going to look at is what happens if we divide by a monomial that involves an imaginary part. And the second part will be what happens if we divide by a binomial that involves a monomial part. One of the things that we need to make sure we remember that when we do division with complex numbers, as long as there is an imaginary part in the denominator, we are not considered to be in simplest form. So we need to get the imaginary part out of the denominator. We can do that by rationalizing a monomial denominator. In order to rationalize a denominator, we multiply both the top, so the numerator and the denominator, by the imaginary part. And then we always want to check to see if our expression can be reduced by factoring out a GCF and canceling. One thing we have to be sure of is that we do not reduce with add and subtract. It is never ever okay to reduce with add and subtract. It's definitely something that I see happen continuously throughout Algebra 2 as well as into pre-calc and sometimes even into calculus. So let's make sure we can fix that as soon as possible. So on number 1, I want to get rid of the imaginary number in the bottom. Well, since I know that I times I equals I squared, which equals -1, if I could change this I in the denominator to I squared, I could then change it to -1 and get rid of the imaginary part in the denominator. So I'm going to go ahead and multiply top and bottom by I, because I can multiply top and bottom by anything I want as long as I do the same to the top as I do to the bottom. So that I has to distribute in on top, so I have to make sure and acknowledge that I'm showing with parentheses that I'm multiplying the entire top by an I, even though parentheses weren't there to begin with. The I distributes in, giving me 3I minus, and then I times 2I is minus 2I squared, all over 5I squared. Well, that then gives me 3I minus 2 times -1, all over 5 times -1, which then gives me 3I plus 2, all over -5. I notice that the top does not have a GCF I can take out, but one thing that is weird is it's kind of weird to have a negative on the bottom, so I'm going to move that negative to the top. So I'm going to say this is the same thing as saying the negative of the whole top over the positive of the bottom, which is -3I minus 2 all over 5. It is not necessary to put it in this form. I will give you credit for this. This is the better form. So those of you who feel like you can push yourselves just a little bit further, make sure that you're always bringing the negative to the top, because like I said, it is the better form. Let's look at example 2. So I look at example 2, and the first thing I notice is that I can simplify that bottom. I always simplify whenever possible. So I'm going to say this is the same thing as 4 plus 6I all over, the square root of 4 is 2 because there's a negative in there. I have to take an I out. So I'm going to say all over 2I. So I notice that this still doesn't put me in simplest form because I still have an I in the denominator. So I'm going to multiply the whole top by I and the whole bottom by I. So I multiply the whole top by I and I have to distribute into each term. And I get 4I plus 6I squared all over. I only have one bottom term, so I'm just going to multiply that. 2 times I is 2I squared. Well, I know I can change my I squareds to -1s, giving me 4I plus 6 times -1 all over 2 times -1, which then gives me 4I minus 6 all over -2. Well, I notice that my top has a GCF, or a greatest common factor, of 2. So I'm going to go ahead and factor that out. And I'm actually going to factor out a -2, so it'll cancel with a -2 on bottom, and then I don't have to worry about having a negative on the bottom. So if I take a -2 out, remember factoring out a GCF is like rewriting it in a form before you distributed. So when I distribute in, I multiply. Therefore, when I take a GCF out, I divide out. So 4I divided by -2 is -2I. -6 divided by -2 is plus 3, all over -2. Now that I have multiplication here, I can reduce my -2's, leaving me with -2I plus 3, or in A plus BI form, 3 minus 2i, because I do not need to write the 1 underneath. I do have one more example to look at. If you'd like to pause the video at this point and try this one on your own, this would be a good example to try on your own. Okay, now that you've had a chance to try one, I'm going to notice that, again, I don't want I in the bottom. There's nothing I can simplify on top. So I'm going to multiply the bottom by I and the top by I. So it has to, on top, distribute to all three terms, giving me 3xi minus 5i squared plus 11i. On the bottom, it's one term. So 9 times I is 9i squared. Well, now I can again reduce my I squareds. So I have two of them, so I'm going to kind of swing back here a little bit, giving me 3xi minus 5 times negative 1 plus 11i all over 9 times negative 1, which gives me 3xi plus 5 plus 11i all over negative 9. So again, this is acceptable. I'm fine with you leaving it in this form, but it is better to say, hey, I'm going to bring that negative up top, and I bring it up to the whole top, so I have to use parentheses to show that the whole top is being made negative, not just the first term, which then distributes to be negative 3xi plus 5 minus 11i all over 9 for my best final answer, although this is an acceptable final answer. And that concludes how you divide with monomial denominators that involve an imaginary number.